Okay, indicator 24, the name of it is rational exponent. So the first thing I want to do is define what a rational exponent is. So does anybody remember what a rational number is? Anybody? It's any number that can be expressed as a fraction. Okay, so rational just means a fraction. And an exponent, you know where an exponent goes, right? So if we look at an example of an exponential expression.
Pardon this interruption for another announcement. After school today, any students that
Okay, so if you look at it, what an exponential expression is, it just means that it has a base, and this should be review, and it has an exponent. Okay, so this right here is your base. Okay, that's always important. And we're familiar with that because when we were adding and subtracting exponents, we said the base stays the base. So we're familiar with where the base is. Also, if you think about it in cheerleading, right, the baseman is who holds up the cheerleader. So in an exponent, the base is what holds up the exponent. Now, in an exponent, we're going to get a little bit more detailed in what the top and the bottom number is. And this will come into play here in a minute when we start talking about radicals and roots. Okay? The top number is what we call the actual exponent. And the bottom number is what we call the root. Sometimes you might even hear it called an index. I will always refer to it as the root, though. Okay? The root or the index. And this is considered exponential form. Should make sense, okay? If it's written with a base and an exponent, it's called exponential form. So this whole thing right here is called exponential form. And we're also going to be looking at radical form, and then we're going to learn how to go back and forth between the two. Okay, we're going to write the same thing in radical form and in exponential form, or they equal the same thing, they're just written in a different way. Okay, so now if we've got exponential form, I'm going to go ahead and erase this base just because you don't need to take up that much space. The other form that we're going to talk about today is called radical form. No surprise, right? It has a radical. And like I said, we get really lazy and we call this a square root symbol. Most of the time, if it's written just like this, it is a square root because square means 2. And that means that there is a 2 written here. Okay? This is also called the root or the index. And again, I'll always refer to it as the root. Under here is your base. So you'll notice some like parts here. Put base back up here. And then, probably going to make this whole thing, I just want to make that smaller. That's okay. Right in here is your exponent. And if there's nothing there, what's there? A 1. If there's nothing on the outside in that root position, it's a 2. So every single radical you ever see, even though you don't realize it, always has an exponent and a root. It's just in math, we never write the exponent of 1 because every whole number has an exponent of 1. And every unlabeled radical is just understood to have a 2, okay? So in this right here is called radical form. Now you'll notice in the two different forms, both forms have a base, right? They're in different spots, but both forms have a base. Both forms have a root or an index. Okay, again, they're in different spots, but both of them have it. And then both forms have, let's do it in purple. Both forms also have an exponent. So you can go, as long as you have those 3 things, you can either write it in exponential form or in radical form. It just depends on where you put the base, the exponent, and the root. Okay, so you can go back and forth between the two. So if we look at an example of that, Let's do example number 1 here. If you have a number given to you, we'll just do a very basic one at first. If we have a number and we have 5, and then we have 2 over 3. You see that okay? Kind of got small there. Okay. This is considered exponential form because it's written with a base and an exponent. We want to write it in radical form. So when you write it in radical form, makes sense, give yourself a radical. Okay? You're going to write it in radical form, give yourself a radical to start building in. Now, where does everything go? Your base, right here, is your base under the radical. Your exponent, which is the upper part of the fraction, always goes in the exponent spot with your base. And the root, which is the bottom of the fraction, is outside. And I always kind of just as a memory trick, the root is under the ground here, and then it's buried outside here. Okay, that's just kind of the way you can remember where the two are. The root in the exponent is always buried underneath, and when you change it to radical form, it's buried outside. Okay, so you can do the same thing. You can go back and forth both ways. So if you have something in exponential form, okay, that's a kind of make it bigger. It's kind of smaller. Okay, you can then transfer this to exponential form. Same thing. Your base is always your biggest number, and that stays your base. And then because it is rational exponents, you're going to have a top and a bottom. And our top is the exponent that's here. And our bottom is the root that's buried outside, stays buried underneath. And then you always simplify fractions if you can. So that would become 13 over 1/2. Okay. And if you were asked to go back to radical form once you've reduced it, you could write it very simply like this. There is a 1 and a 2 over there in that final square root 13. But this is how you will see it written most of the time. Now, I don't care if you want to write the 1 and the 2 there. You can. It will never be wrong or right. But there is a 1 here. That's your exponent. There is a 2 here. That's your root. Those are just the ones that are never written. Okay? So this and this are the exact same thing. Exponent and root are understood in this example. Okay? All right. Let's do a couple more examples here. All right, so if we have, we'll get a little bit more, when I say complicated, I use that term very loosely. This is a very easy indicator, or at least today's is. Okay, so we have it in exponential form. We want to write it in radical form. Always give yourself a radical to start building in. Your base here is still your base. Even though there is a number and a variable with it, the whole thing is still your base. Oops. So in the base spot, you're still going to write 6a. That's still your base, no matter how big it gets, okay? Because remember in math, when two things are multiplied, it's like they're married. When you get married to become one, so that is considered one term, okay? Now, you want to write your root and your exponent. Your exponent's on top. It stays your exponent with the base. Your root goes buried outside, okay? That is this rational exponent written as a radical. Okay, another, quick example here. Looks very much the same. Let's do 4b raised to the power of 7 over 3. We want to write it in radical form. So I'm going to give myself a radical to build in. My base is just that whole base. So 4b is my whole base. I'll write that a little bit better. 4b is my whole base. My exponent here is 7, and my radical is 3. Okay, and because I don't know what b is, I can't reduce this any further. That's just written in radical form. Okay, let's see. Now we want to practice going the other way. Now, when you're going the other way, there's an extra couple of steps. And so I'll show you what those are. So let's start out in radical form. And we've got 6, 2a, and 7 is my exponent. Sorry, when you're just switching forms, there's not an extra step. My brain's jumping ahead of me. Yes?
On example 4, how's the exponent 7? Oh, I thought it was 2. Sorry.
That's okay. No, you're good. Always ask, especially when my writing kind of gets really, I have to hover my hand above the screen, and so my handwriting gets quite atrocious on this thing. Okay, so we've got, it currently is in radical form. We want to write it in exponential form. Same thing, your base stays your base. 2a is our base. Our fraction is going to be made up of the exponent, which is a 7, and our root, which is the 6. So our exponent is 7/6. The only extra step here is if the exponent can be reduced, which in this case it can't, go ahead and reduce it. Okay? So here we won't, but I'll just write it out to the side just so you have it. Reduce if possible. Reduce the fraction, that is. All right, a couple of other just quick examples here. This honestly, this is as hard as this part gets. It's pretty straightforward. We've got one other thing we want to talk about, but it's not any harder. So if we have this, and you have to write it in exponential form. I'm sorry, yeah, exponential form. It's in radical form. You have to write it in exponential form. To write it in exponential form, you have to have a fraction. So you have to know the understood numbers that are here. You have to have a fraction as your exponent, which means you have to have a top number and you have to have a bottom number. Okay, they're not there, but they're there. There's always, I'll write it in red here. There is always, even when it's not written, there is a 1 here and there is a 2 here if nothing else is written there. So it's an understood 1/2. And you can't just leave it x with that understood 1/2 because 1 in the exponent spot and 2 in the root spot looks different when you put them together and make a fraction of 1/2. So you can't just leave it, and don't write this in your notes because I'm going to erase it here in a second. You can't just leave it x with the understood 1 and understood 2, because if you just leave it x, what's the understood exponent? It's a 1. So even though there's an understood 1 and 2 in the radical form, you actually have to write those out as fractions when you go to exponential form, okay? All right, so the last little piece of this indicator, day 1, is we're going to simplify. So the first 6 examples I gave you was just simply going from rational form to exponential form back and forth. So on your homework, pay attention to the directions because there's 3 separate sections. One says put in exponential form. One says put in rational form or radical form. That's these first 6 examples. The bottom few actually says simplify. So we're going to change our directions a little bit here. And now we're going to start simplifying. And this is where a few of your extra steps comes in. So this is example number 7, and now we're actually doing an example where we're going to simplify. So we start out in exponential form. So we have 125 raised to the 2/3 power. Now you cannot simplify this in exponential form. Okay, you can't. You don't know how. You could do it in a calculator, but we're going to pretend you don't have calculators, okay? So especially on your homework, yes, can you punch this in a calculator and just write the answer? You can. Does that get you credit? It does not. You have to show what I'm about to show you as far as the work that goes with it. So the first step is putting it in radical form, because once it's in radical form, we know how to simplify it. So in radical form, our base stays our base. Our exponent is a 2, and our root is a 3. Okay? Now remember last time I told you that root is kind of like your marching orders, or it's your directions. It tells you how many you have to circle before you can pull them out as one. And we've gotten very comfortable with square roots. So you're going to have to really watch this indicator of what that root is, because your root's going to be something different every time. Might be a 2, might be a 3, 4, 5, 6. Whatever that is, that means you have to have that many. Think of it in poker. 2 of a kind, 3 of a kind, 3 of a kind, 4 of a kind. You have to have that many in order to pull them out. But when you circle them and pull them out, they still come out as 1. So if I factor 125, okay, and ignore that exponent right now. That exponent, this right here, that is your very last step. You ignore that for right now. So you're just going to factor 125. Well, it's 5 times 25 and then 5 times 5. Okay, we're used to getting to this part, right? But what we're used to doing is circling our pair and pulling them out as 1. Our root this time is not a pair. It's a 3, which means we have to circle triplets before we can pull them out as 1. Okay? Anything left over? No. So it's perfect in that it's a perfect cube because it perfectly comes out as 3. And now you apply that exponent and you reduce it all the way that you can. And we know that 5 squared is 25. Now, looking at this original problem right here, right, could you have in your head without a calculator said that 125 raised to the 2/3 power is 25? No. So that's why we turned it into radical form. Then we know how to work it by reducing and simplifying the radical by pulling out any perfect groupings. I'm not going to say pairs anymore because they're not always going to be pairs. You pull out a perfect grouping and then you apply the exponent. Okay, so if you're a steps person, you don't have to write these down. Some people are, some people are not, so I always write it. Step 1 is going to be putting it in radical form. Okay, that's step 1. Step 2 is factoring just the base. Whoops, my handwriting. We factor just the base, but remember when you factor the base, right? Step 3 is group based on the root. The root's going to be what gives you the directions here, okay? Turn it to radical form, factor your base, group your factors based on your root, and then step 4 is apply, I don't know why I kept putting arrows there, apply the exponent. That's always your last step, okay? So let's try another example here. Let me add, let's add paper here. All right, so we're going to do just a couple more examples, and then I'll give you your homework. And your homework is pretty straightforward, so we're doing good on time. All right, so this is example number 8, and we're still under the simplify heading as far as your directions. So that's what we're going to be doing here. So if we have 64 raised to the 4/3 power. Again, definitely not something that you could just solve in your head. So we're going to follow the steps. The first step is we are going to put it in radical form. So I'm going to give myself a radical. I'm going to put the 64 as the base. The exponent is a 4 and the root is a 3. Okay, now we factor our base. So we factor 64. It's even, so we're going to go with 2. So that gives me 2 and 32. Now, you're going to throw out what you know, because 64 in a couple of indicators ago would have been super easy, right? 64 is perfect, 8 and 8, circle it, pull out your 8. Because we're not dealing with square roots here, that doesn't help us. So you kind of have to detach what you know about factoring as far as perfect squares here. And we really do want to go all the way down to the bare prime numbers, okay? So 32 is 2 and 16? 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. All right, I'm all the way down to my bare prime factors. Again, you have to look at your root. Here our root is a 3, which means I'm going to circle triplets. So I circle 3 2s, and when I circle them, they always come out as 1. No matter how many you're circling, they come out as a single 2. I have another set of triplets here that I'm going to pull out, and just like last indicator, when you have 2 times 2, you simplify it to 4. Now we're going to apply our exponent. Remember, that's the last step, is apply the exponent. And then 4 to the 4th power is 4 times 4 times 4 times 4, which is 256. So that is your simplified answer. Okay, and again, I know that you can punch in your calculator 64 raised to the 4/3 power, and you're going to get 256, but I need to see all of that work in the middle, okay? All right, let's see. Let's do a couple more quick ones. Okay, example number 9. Okay, we've got 81 raised to the 1/2 power. And once you get going on this, you might recognize that anything to the 1/2 power is that real basic square root. So if we give ourselves a radical and we write our base, our 1, the understood exponent, is a 1, and our root is a 2. So you can even simplify this even more if you just wanted to write it like this. Anything to the 1/2 power, that is your basic square root, nothing fancy. And then, right, this one is easy to do. Because it's a square root, we know that it's 9 and 9. And you don't make these harder than they have to be, but just know that if it's not a square root, you really have to factor all the way down to the bare bones, the bare prime factors. If it's something you get to this point, and because it's to the 1/2 power, it's a very basic square root, you don't have to factor this 3, 3, 3, 3. You can do a square root like you know how to do, which is it's perfect 9 and 9. Okay? So 1/2 power or 1/2 powers are nice because they're just basic square roots. All right, we'll do one more and then we will be done. So we have 8 raised to the 5/3 power. All right? Yes. 8 raised to the 5/3 power. So the first thing we're going to do is we are going to put this in radical form. So our base is 8, our exponent is 5, and our root is 3. Then we are going to factor 8, and it is 2 and 4, 2 and 2. And our root is 3. If it helps you, circle it, highlight it, point to it, arrow it, whatever you want to do in your homework to help you remember. But that means we need to circle triplets. When we do, they come out as 1. Now we can apply that exponent. And 2 to the 5th power is 2 times 2 times 2 times 2 times 2, right? Big common mistake. 2 times 5 is 10. That is not 2 to the 5th power. 2 times 2 all the way 5 times is 32. Okay? And you do not have to put this in your notes, but I just want to show you something. If we would have had, and again, you've got enough in your notes, I think you're good. If you had 8, excuse me, and the fraction had been flip-flopped, okay, that's okay. You still put it in radical form. Your exponent is your exponent, and your root now is 5, okay? And when your root, oh, not 8, sorry, that was supposed to be 32. I was trying to do it backwards, and hang on. There we go. Sorry. So if you're doing it, if you've got a root that high, don't let it mess with you. Still factor. So you would get 2 and 16, 2 and 8, 2 and 4, 2 and 2, right? And then your root of 5 tells you that you've got to have 1, 2, 3, 4, 5 before you can circle them. If you don't have 5, they stay trapped. But in this case, you do have 5. And so because you have 5 of a kind and your root is 5, they all come out as 1. Then you would apply the exponent and you would get 8. Okay, so no matter what your root is, that's how many you circle. When you can circle them, they come out as 1. And I'm almost 100% sure all of these are perfect. So if your root's 5, you're going to have 5. If your root's 2, you're going to have a lot of pairs. If your root's 3, you might have a bunch of triplets, but it should always be perfect, okay? All right. You've got the rest of the hour. I have a feeling that you will get this done. So when you do, let me know, and I will have the key up on my screen so that you can come check it really quickly. Need to take it. Are we missing Cameron today? Is that it? I think I got really short on some of those back, so pass them along the back row if you need to. I should have a couple extras, so there should be enough for everybody. Everybody left it now. There you go. Look at your directions. That first section says write them in radical form. The second section write them in exponential. And that bottom section is where you start simplifying. For those of you at home, if you have any questions, let me know. Otherwise, click load on the screen and it'll bring this assignment up in Kami. And make sure you show all your work just like we did in the video.